All right, section 6.6. This is kind of a combination of things we've already done before. We're just kind of putting it together. Okay, we know the title of this thing is called coordinate geometry. Like, what's the first thing pops in your head when you think of coordinate geometry? Coordinate plane. Okay. What's a coordinate plane? Graphing. Okay. Yeah, absolutely. All those things are true. Yep. All right, so here we go. This is what they give you. I'll tell you what, let's do this. Let me grab this one instead. Is that right? I don't know if that's going to help us. Let's see. Yeah, that should be good. And let's put that right there. Let's make this a little bit bigger so we can actually see it. There we go. All right. So here's what we're going to do with this stuff. And you're right. You're going to have to know some things about like slope, distance. Remember the distance formula? The slope. Let's see if there's anything else we need to know. Midpoint. Remember how to find the midpoint between 2 points? Well, hopefully I'll be able to refresh your memory a little bit so you can do some of this. So let's do this. They just start off right with an example. All right. Again, we're not really learning anything brand new. We're just combining some of the stuff we did with that coordinate and the graphing with the quadrilaterals that we've learned. Okay, we've learned, name me a few of the quadrilaterals that we've learned about. Rhombus, rectangle, square, a kite. What was like the big one that trapezoid. What was the big one that we learned a bunch of stuff under? Yeah, parallelogram, okay? So we learned a bunch of things about it. So I'm just going to give you some points, and I'm going to tell you what we're going to try to find, okay? So point A is -1, 3. And we are going to graph this in a second. I'll tell you what, let's do it. Let's put it this way. Point B is 3, 2. Point C is 4, -2. Point D is 0, -1. All right, and what they ask you to do, they say classify this quadrilateral ABCD. So it's a four-sided figure, okay, but we don't know what kind it is, okay? Is it a parallelogram? Is it a trapezoid? Is it a kite? Is it all the other parallelograms? What are the stuff underneath parallelogram? What are some other parallelograms? We've already mentioned them. Rectangle, rhombus, square, okay? Kite is not a parallelogram, all right? But the other ones we mentioned. So we want to be as specific as we can. Now, we could just look at it after we graph it and just guess what it is, and we might guess right, all right? It might not be much of a guess. It might be a pretty educated guess because we see the shape of it right in front of us. But we're going to have to show why it is what we think it is, all right? So we have to classify quadrilateral ABCD as specific as possible. Let's try to put the P first. Specific as possible. All right. Well, what's the first thing that you would do if you had to do something with this? Put the points on the graph. Exactly right. So let's do that. I tell you what, just to make this a little bit easier to see, instead of just counting over 1, because we don't really go that far, do we? Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, this will work out perfect. Instead of counting over 1, let's count over 2 for each one. Is that all right? Just to spread it out a little bit more, because it'll be too squished, I think, if we just counted over 1 block for 1. So instead of -1, 3, we're going to go what? To here. Everybody see that? So right here, this will be 1, this will be 2, this will be 3, and this will be 4. Okay, this will be 1, 2, 3, and 4. This will be 1, 2, 3, 4, and let's keep going this way. 1, 2, 3, and 4. You understand why I'm doing that? I'm just doing it just so we spread it out. It's just a little bit easier to look at. So negative 1, 3, what would that be? It would be negative 1 and 3. There's 1, 2, 3. So that would be point A right there. I'm sorry. I went the wrong way, didn't I? I went negative 3. It's negative 1, positive 3. Why did I go negative? I don't know. It's negative 1, positive 3, so it would be right here. Yes? There we go. That looks better. B is 3, 2, so it's 1, 2, 3, 1, 2. That's B. C is 4, negative 2, so 4 goes all the way out to here, and negative 2 goes to here. And then 0, 1, or 0, negative 1 would go right here. By the way, that's C, and that's D. All right? But is a parallelogram as specific as you want? No, parallelogram's not that specific, is it? Because there's a lot of things that are parallelograms that this could be. Might be. But we got to figure out for sure what it is. Okay? Looks like it's a rhombus, doesn't it? All right. How would I know if it's a rhombus or not? I could do it a couple different ways.
2 of the sides are equal.
2? To be a rhombus, just 2 of them? All of them. All 4. So, excuse me, I could do this. I could find the length of all 4 sides. And if they're all the same, then guess what it is? It's a rhombus. Okay? But I could do something with less steps. That's 4 things I got to do, and I got to do distance formula. Distance formula is kind of long, isn't it? All right? So I could do that if I wanted to, and it would work, but I'd have to do it 4 times. Is there something else that we know about a rhombus that I could do to it in order to say that it's actually a rhombus? Well, I could say that like these 2 are parallel, these 2 are parallel, but that would just say that it's a parallelogram. But that's not very specific. I could get way more specific than just saying it's a parallelogram. All right? So just saying that these 2 are parallel and these 2 are parallel, that's enough to say it's a parallelogram, but it's not enough to say that it's a rhombus.
Maybe like
A, B, and DC? No, we have to show all 4. Just because these 2 are equal, I'd have to show all 4 are equal. But remember, we said I don't want to really do that. You could do slope, but again, what is a slope going to do? Finding the slope of this and this, if they're equal to each other, it means they're parallel. Could find the slope of this and this, means they're parallel. If I did that, that's still 4 things I got to do, right? Yeah. I just had to look at my notes for a second just to make sure I was going to do this right. What else did we learn about a rhombus, though? We went more specific. Just fairly recently, we learned about a rhombus. Not just the sides. What haven't I marked here that I could?
angles. The midpoint.
The midpoint? That helps us say something about a rhombus? What haven't I drawn yet that we've talked about a lot? What about, what bisects? They're not transversals. What is it called? That's what I'm asking.
What are the bisecting things?
I know what it is. I'm asking you what it is. What is it? Did you say it, Taylor?
That's what I see, right?
The diagonals. Taylor said it.
There it is.
The diagonals. So what do we know? If this is a rhombus, which we think it is, right? Looking at it, it sure looks like it's a rhombus. Would you agree? All right.
Yeah.
If it's a rhombus, then what must be true about the diagonals?
It must be.
Are they on a rhombus? Say it.
Bisect.
No. Well, it's true they will bisect each other, but they would bisect each other if it was a rectangle, or if it was a square, or any parallelogram, right? But specifically about a rhombus, because again, we want to be what? As specific as possible. So just saying that the diagonals bisect each other doesn't really give us that it's a rhombus, because that would be true about any parallelogram, right? Any parallelogram that the diagonals bisect each other. But more specifically, look at it. Look at the 2 yellow lines. Say it, and I can't hear.
Perpendicular.
Perpendicular, correct. That is what's true about a rhombus. Everybody see that? So if I can show that this and this are perpendicular to each other, then I could say that that thing's a rhombus, couldn't I? How do I show that they're perpendicular to each other? I got to find the what? How do I show that two lines are perpendicular? Let me ask you this. What if I had a line? Oops, what's that? What if I had this? Oops, come on. There we go. What if I had that? What does it look like is true about those two lines? They're parallel. What must be true about something about those lines if they're parallel to each other? The slopes have to be equal to each other, okay? What if we had a line, let's get rid of that. What if I had a line that was, what if it was perpendicular to each other? We said if they were parallel, the slopes would be equal to each other. But what if they're perpendicular to each other? What's true about the slopes? Don't let that shut all the way, because if somebody wants to come in. What is it? It's close, half of it. It's not just reciprocals of each other. What word did I use? We've said this a whole bunch. We've had quizzes on it. It's been on a test. Well, she said reciprocal, and I said that's half of what you want to do. What is it? A negative reciprocal. That's right. Okay.
Good job, Gianna.
So it's all coming back. Guys are scaring me. All right. So what do I want to show? I want to show that the slope of one line, we'll call it, let's just use the letters. Let's call it AC. All right. We want to show that the slope of AC must equal the what? The negative reciprocal of the slope of what? BD. Okay? So what I'm going to do is I'm just going to find the slope of both of those yellow lines. Okay? If I can find the slope of both of those yellow lines, and if I look at them and they're negative reciprocals of each other, then guess what's true about those two lines? Then they are perpendicular. If those two lines are perpendicular, they're diagonals, that means this thing right here, ABCD, has got to be a what? A rhombus. That's what we're trying to do. Is it making any sense at all? Or am I just the Charlie Brown teacher? You know what the Charlie Brown teacher says? Anybody watch Charlie Brown? Yeah, wah, 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 wah. Exactly right. Okay? Sometimes I feel that that's all you hear coming out of my mouth is wah, 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 wah. Can you let me do the impressions? All right. So, what are we going to do? Let's find the slope of each of these lines. So let's find the slope of AC. So slope, and I'll put a little AC right there. How do we find the slope? Change in what? Yeah, rise over run, but the change in what? I say it all the time. Change in, what's on top? The change in the what? Did we just learn this for the test and then forget all about it? The change in what? It's rise over run. It's not the change in X, it's the change in what? Y. It's the change in Y over the change in X. So we subtract the Y's from each other. So we're looking at line AC. So here's A and there's C. See it? We're finding the slope between those two lines. So what do we subtract on the top? The Y's. So it doesn't matter what order as long as you subtract the X in the same order. So I'm going to go 3 minus what? Negative 2. 3 minus negative 2. Okay? Now I subtract the X's in the same order. If I went the first one minus the second one, I'm going to go the first one here minus the second one. So what's that? That's negative 1 minus 4. Let's do the math. 3 minus negative 2 is 3 plus 2, which is 5. And then this is 1 minus 4, which is add the opposite, which is negative 5. And what is that? That's negative 1. So the slope of this one right here is negative 1. Everybody see that? All right, let's find the other one. What else are we going to try to find the slope of? The slope of what? BD. All right, so I'm going to put slope of BD. Now, the cobwebs are out of your brain now, right? So you should know how to do this. BD. So I'm going to take this one and this one. All right, so the change in Y, what do I do? 2 minus negative 1. The change in X, 3 minus 0. Good. What's that? 3 over 3. And what's that? positive 1. So take a look. There's a slope of one line. That's the slope of the other. Are they negative reciprocals of each other? They are, okay? Because one's negative, one's positive. That means they're negative. That's the negative part, okay? Are they reciprocals of each other? Sure, because what's 1? 1 is 1 over 1. If I flip 1 over 1, what do I get? 1 over 1. So are they reciprocals? They are. Are these negative reciprocals? Yes. So what's true about the two yellow lines? They're perpendicular, okay? Which means if they're diagonals of a quadrilateral and they're perpendicular, what does that mean about the quadrilateral? It's a rhombus. So I just showed that this thing is a rhombus. Okay? And that's what they're asking you to do. Okay? They give you a quadrilateral and they say classify. That's the word they use. I'll just write it down so you see it. Okay? They say classify the quadrilateral as specific as possible. If you just said it was a parallelogram, it's true that it's a parallelogram, but is that as specific as you could get about it? No. You could get more specific than a parallelogram. All right? And in this case, you would say it's a kite. Again, there's another way to do it if you wanted to. I could find the lengths of all four sides. I could do the distance formula. But then that's 4 things I have to do. You understand? What would you rather do? 2 slopes or 4 distance formulas? 2 slopes, absolutely, okay? I mean, the distance formula is like twice as long as just doing 1 slope, right? So yeah, it's way better to do it like that. But you could. You could find the length of AB, the length of BC, CD, and DA, find all 4 lengths. If they're all the same, then you could say it's a rhombus because a rhombus has all 4 equal sides. We good? All right. Let's see what else we can do. Yeah, it's good enough. I did something else with that, but I'm not going to. I think that's fine. Let's grab this thing again. Yeah, let's grab this. And put it right here. Scooch it over a little bit. All right, let's do another one. This is example 2 in the book. Example 2. It says, I'll just write the whole thing out, okay? Find the coordinates. So we're finding a point, okay, actually we're finding 2 points, of point F and point G if the diagonals of parallelogram, right? That's our little symbol for parallelogram, EFGH, EFGH. So they tell you you're going to have a parallelogram, and they intersect. What intersect? The diagonals intersect at, excuse me, at point T, and they tell you what point T is. It's 3, 2. Like, what in the world's going on here? Well, okay. First thing I would do, what's really the first thing, the only thing you could do right now? Graph what? T. The 3, 2. Right, the 3, 2, the T. So I come over. Should we, let's just use 1 instead of going over 2 like we did the last one. Let's just go over 1, okay? So this is 3, 2, so it's 1, 2, 3, 1, 2. That's point T. What is point T? Point T is where the what? The diagonals do what? Intersect each other, all right? So the diagonals are going to intersect each other somehow. Everybody got it? All right, and it's a parallelogram. So what we would do here, let me think a little bit here. I wrote down the steps. I want to think of a good explanation. Let me go back to what we talked about in the last one. If I had a parallelogram, I'll tell you what, let's just draw. Let's make this white. So this is just going to give us a little foundation for what we're going to do here in a second. So just bear with me here. So I'm going to make this kind of look like, this isn't necessarily looking exactly like the parallelogram that's on the graph. It's just any old, plain old parallelogram, okay? And I just want you to see something else. We actually mentioned it earlier about the diagonals of a parallelogram. Now, if it's just an ordinary parallelogram and not a rhombus, there's basically, let me think, I'm pretty sure I can say this safely. There's basically only one thing that we can say about those diagonals of a parallelogram. What do we know about the diagonals of that parallelogram? They bisect each other, exactly right. So that means that this and this are equal to each other, and this one and this one are equal to each other. Everybody with me on that? On this over here, again, what's that red dot represent? It represents where the what? Diagonals intersect. So basically, it's that point right there, isn't it? Okay? So that means, now watch, from one end to here is the same distance as it is from here to here. What we're going to do is we are going to use, I'm trying to think of an explanation of what I'm going to tell you to do right here. And I didn't. Give me a second. Don't talk while I'm trying to think here. I think what we're going to do is we're going to start at the origin and put a point right here. Okay? So if we start here, and this is this point here, then where is the other point? And this is one corner of my parallelogram. Where's the point going to be up here? So let's think about this. How did I get from this point to this point? I went, you could rise, run, or run, rise, or it doesn't matter. I went over 3 and up 2, didn't I? All right. Well, to get the other endpoint of my parallelogram, what can I do from here? Since this is the midpoint, I do what? I go over 3, 1, 2, 3, and up 2. Would you agree that would be the midpoint of this? All right. And where is that point then? Just by looking at my graph. 1, 2, 3, 4, 5, what? 6. 1, 2, 3, 4. Correct? It's not what I'm trying to do. Hold on. I'm sorry. I should have had this better prepared for you. Midpoint is that. Then that's the midpoint. I think did they give you another point? Let me look at, maybe that's what it was. Maybe I didn't write that in my notes because it seems like I'm missing something, but let me see. So this is what, 6, 6, example 2. Because I never teach right from the book. I always teach from the examples. They do, and I should have known that. See, I have it written down, but I thought we had to figure that out. So I tell you what, that was we could do that, and that would be fine. But they also tell you, and I should have known this, they do give you this point right here, and they also give you another point, which is 4, 1. 1, 2, 3, 4, 1. Yes, right there. You know what I'm going to do? Sorry. You guys are being so good, and I'm messing up. Let's do this. Let's put everything by 2s, all right? It was going to be way too squished because my parallelogram would have been like this big. That's way too small. So let's just do this again. Let's go 3, 2. So where's 3? There's 1, there's 2, there's 3, there's 1, there's 2. Nope, because I'm going to be off of there. Let's just go back to what we did. Sorry. Okay, and we'll just do that. We know that point's going to be there. I'll show you how to get it in a second. without just counting. So they say 4, 1. So 1, 2, 3, 4, 1. Yeah, it's going to be, it's not going to be too bad because remember, this isn't the end point. This is the midpoint, okay, where they intersect, where those diagonals intersect each other. So this is 4, 1. And this is point H. This is point E. They tell you that this point exists right here, all right? I don't know. I thought the only thing they told you was this information, but they do tell you some stuff here. They tell you that this is point T and that it's at 3, 2. And what we have to do, we already have E, don't we? We already have, what's that, H? We just have to find F and G. Would you agree? Well, we can find G kind of already. We did that already, right? So if I went over 3 and up 2, let's just do it that way. So I could do what? Go over 3 and up 2 right there. So what's that point right there? We could call that G. See that? Because that's the intersection. We could do the same thing here. How did you get to the corner of the parallelogram here? We went what? Down 1 over 1 or over 1 down 1, right? So how are we going? If this is the midpoint, then how are we going to get to this? The other one? We go what? Up 1 over 1 right here. You see that? And there is our, and that's our points. That's our missing points. So there, just drawing our parallelogram out. Okay? And there it is. There's our parallelogram. What was this point then? This point right here. We could just count on our graph. What is it? 2, 1, 2, 3, 2, 3. And what is this point up here at G? It's 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4. So that's at 6, 4. And there's all the coordinates. So they say, what do they ask for? Find point F, and that would be this one right here, wouldn't it? Didn't put the letter. And then point G is this one right there. So that's what they're asking for. So my answer is F is at 2, 3, and G is at, where? 6, 4. And that's what they asked for. I did it a little different than it's in my notes. I did it kind of more algebraically in my notes. But looking at this, I'm like, I think we can just do it like that. All right? So watch. From here to there is one diagonal. And then from here to here is another diagonal. Everybody see that? Now, they're not necessarily a 90-degree angle right there. Why not? Because this thing's not a what? It's not a rhombus, okay? We don't know that it's a rhombus, but because look, that diagonal is definitely shorter. Well, actually, that's only on a square anyway. But anyway, they still bisect each other. And so how did I know to get to this point G right here? I know if that's the middle of this line. How did I get to that? I just went over this far and up that far. Then I do the same exact thing because that's the midpoint. I go over this far, was that 3 and up 2? Then I got that point right there. Got it? They give you this point here, so I know from here to here is the same as from the middle to this point. So I just what? Went over 1, up 1, and then I get to the other point. I go over 1, up 1, the same, and then there you go. There's the points. What do you think? I can't hear you. Well, it's because they put it in order, E, F, G, H. So if this is E and H, this can't be G because you can't go from E to F up here. You have to go in order around the thing, okay? All right, so we went E, F, G, H. Good question, though. Does that make any sense? So that's the kind of stuff they're going to ask you to do. When are we out of here? 2:15? Yeah, I don't think I have enough time to start the next thing. The next thing's a little bit different. It's similar to this, except they're not going to give you actual points here. All right, instead of a point, they're going to call it like AB. All right, and I won't give it away. Tomorrow's going to be a little bit weirder, but it's going to be very similar to what we just did. All right, and it doesn't mean it's harder just because it's weirder. All right, it's just a little different, just a little different. You have to think not just with numbers. You're going to have to think with letters. But what do letters do? They represent what? Numbers, okay? So anyway, that's a little sneak preview for tomorrow. And we will do that tomorrow. What's today? Wednesday, Thursday. Yeah, and then we'll probably review for the test on Friday, and we'll probably take the test probably Monday. Everybody okay with that? All right, so we'll finish this up tomorrow. Friday we'll review for the test, and then we'll take the test on Monday, and then corrections on Tuesday. Everybody good? Okay. I think I gave you some assignment, didn't I? Coordinate 1 through 7. All right, so that shouldn't be too bad. 1 through 7, and this is section 6.6. I think you should be able to do all of those, I'm pretty sure. All right, that's it.